Hello, and welcome back to the second part, Chapter 1. The next thing I want to discuss is how databases have enabled the big data explosion. And so we now have the ability to gather much more uh, different pieces of information, different types of information, and we need a way to store that. So the databases and the hardware has grown in speed and in size of being able to store all that data. And so now our database management systems can handle terabytes of data. Everything is much faster. We have faster processing, better storage, better retrieval, and so that has enabled this big data explosion. Along with that increase in speed and increase in size of the ability to store data, that cost has gone down. And as the cost has gone down, now people are starting to think, okay, it's not going to cost me as much to store that data, even though I'm not using it in reports. And so they're actually grabbing more information, more data as they're collecting it. And you see this in your social media examples, like Facebook, Instagram. They're just grabbing that information, even though they're not doing anything with it yet. And so, but eventually they will. Also related to that is the ability to store and retrieve things in the cloud. So that's even making it lower cost and faster, and the ability to do it from anywhere. And so what are companies doing with this data? They need this data for immediate analysis. They've got to make sure that it's accurate and that it's complete. They've got all the information. What I mean by complete is, let's say we're collecting a customer's address. Well, what if they just type in their last name and they don't give us a first name? Or they type in the street address, but they don't give us the state or zip. And so that would be incomplete data. Companies also need to have that data not be redundant. That is, the same type of data stored in multiple tables. So I wouldn't want to have a customer's address stored in different tables, because what happens when that customer leaves or changes addresses, I should say, and I only update that address in one table, but yet I'm using other tables to email them or send them something in the mail. So then I'm wasting my money, because now it's going to the wrong address and the wrong customer. And so one thing with the relational databases is that you can ensure that the data won't be redundant, that it won't be stored in multiple places. And we'll talk about that later on in the chapter. And another thing that has also enabled this big data explosion is the creation of object relational models. And what this means is it's an extension of the relational model that allows us to store and use non-structured data. Non-structured data is data like pictures, drawings, video, audio clips. So we're now able to analyze that non-structured data. The next thing I want to talk about is the history of databases. In the past, database design was the job of the IT department, and there were professional database developers. These people usually had a background in math, computer science, or systems design. As you can see here, here's an old IBM mainframe where there was one person putting in cards or typing in instructions in order to generate reports. And so this is around the 1960s, and so they were the big computers were probably mainframes, as I said, and they weren't available to the general organization or workforce. And so if you were a supervisor, you couldn't just go down there and run your own reports. You had to put in a request. The request was then evaluated to see, okay, what's the priority for this request, and depending on the priority and who was requesting it, then it might get run the next day, and it might be, a couple of months down the road. So big problems there. So with this, you also had to have some specific training and know about programming languages and databases. We talked about SQL before. You probably had to have some training in that. And so with this, all this data that was just now being collected in the 60s, you had different types of networks that were being developed. I shouldn't say networks, but databases. So you had the hierarchical database and a network database. Each of those databases wasn't really very supportive of how work was actually done. They were one-directional, very complex, hard to navigate. You couldn't just go in and make changes to the structure of the database without going back and rewriting all the other programs that use that database. So usually when something was written, it was very difficult to go back and make changes in that. So then when the personal computer came about in the late 80s, early 90s, now people could create their own databases and run their own reports. And this made it much more convenient for people to get that data and make decisions with it. Then in the mid-90s, you had the commercialization of the internet. And so now you had huge volumes and frequencies and different types of data that companies just weren't used to handling or seeing before. This meant that the people that were making decisions now had to have faster computers and databases that would help them manage and produce reports in a timely manner so they can make quicker decisions. And so what we have now is it's not a matter of if a company can gather and use the data, it's a matter of how the data will be used. And that has caused some problems recently in terms of ethics and privacy concerns of how people's data is being used and are they being manipulated. And so that's one of the reasons you're involved in taking a ethical certificate. How can you be more ethical, aware of using data and making the best decisions with that and not being unethical with the data. This leads us to the advent of big data. And so as you can imagine, it has its influence from the internet and how businesses have been using the internet in order to gather data and improve how their businesses run, or actually how all aspects of their businesses being done, from suppliers to their customers. And so with the advent of the internet, we have different ways that we can collect that data. And so one way is using loyalty cards. If people have membership, every time they use that membership card, we can track what they're doing, what they're buying, what they're using it for, and so on. If you think about it, if you go to Starbucks and buy coffee, they're tracking you every time you do that. So they know where you went, what time of day that you're buying the coffee, and so on. And so if they want to try and advertise to you when you might be able to go and buy a cup of coffee, they know what the time frame is in order to do that. And so they're using all that data and trying to develop a pattern or see a pattern with their customers and who's using that card at certain times of day. And then they'll send out specific marketing slogans and things to those people for those different times of day. So with that, we have to collect the data, and so that data can be collected in a centrally located database, and we can have security settings that would allow or disallow certain access on that, or we could have distributed databases where they're distributed across a geographical region, and we could have fully distributed where there's actually a copy of the entire database that exists at each location, or partially distributed where only a copy of that exists. An example might be, if I'm a bank, do I have a copy of my entire bank's database at each branch location? Or do I just have that copy of the database where my customers typically do transactions at that branch location? So if I know that a certain customer goes to a certain branch most of the time, and that database is sitting there, that partial database that just contains the records of those customers that go to that branch, it's going to work much faster. Now, if I walk into a branch that I don't typically go to, they can still look up my information, but it may take longer because it's going to have to go across some kind of network in order to hit the other location where that database is in order to retrieve the data. So those are things that we're going to be talking about as well, in terms of being able to partition that database, or at least think about what is best for the organization in terms of speedy retrieval. Now, as this relates to data analytics, we've got all this data that's coming in, and so now we have a need in an organization to find people that will help us gather the data, clean the data, and organize the data. So in some ways, we've kind of come back around to the way we had IT folks providing the output again. But now that output is much more dynamic and much more informative. And so if you look at certain type of systems, now we can produce dynamic, interactive models and visuals that allow people to interact with the data to see what might happen and to be able to analyze those results. The next thing I want to talk about are some common database design problems. One thing you need to keep in mind that a poorly designed database can be more detrimental to your company than not using a database at all. And so making decisions based on those inaccuracies or missing data will lead to bad decisions. And those bad decisions could actually cause your company to go under. So that would be a catastrophic decision. So if you're going to use a database, you need to make sure it's designed properly. So the different types of problems that you might have are application problems and data problems, and we'll talk more about that here in a second. So when we look at application problems, those are usually the result of an inexperienced database developer. That is, they probably don't have the correct training, they're not familiar with the database software, and they don't understand the business processes. So problems that you get from poor application design is you have problematic data entry and edit forms, so you're not collecting all the data, or it doesn't seem consistent on what you're asking for, or you don't have everything listed on the screen that needs to be input, and you don't have a good way for somebody to edit the forms. Also, the menus and the toolbars might be confusing, which means then the user who's using that application doesn't know how to use it properly. And if you also have confusing dialog boxes, things that pop up when there's an error, typically if you leave something off on a form, you want to have a box pop up and tell the user, hey, you left this off, you need to provide information here. That needs to be concise. And if you left off a name, you don't want to say, hey, you need to fill in the customer information here. Well, what customer information is that? Is that the first name, the last name, middle initial, what? And so you got to be as specific as possible so that end user isn't trying to guess what it is that the system needs. Also another area for poor application design would be, a very tedious task sequence. A lot of times I've gone into businesses and somebody's working on putting information into their database, they put in information on one screen, and then they have to flip back to another screen, put in information, and then flip back to the first screen to put in the rest of the information. Doing that and having to learn that or train somebody means that they may not always get that in the right sequence, which causes problems. They get frustrated with the system and they just say, forget it, and don't put in the data at all. Or they do the minimal amount and they're missing pieces of information or data that gets into the system. The problem with that is that then when you go to run reports where you're aggregating the data, that is, you're summarizing it, you might get an average of something or a sum of something. That because it's got missing information, you're not getting an accurate result. So now you're making bad decisions with that. Now, in terms of the data problems, this is probably the result of a poor database design. And that means you probably didn't involve the end users in that design process. So I always tell people, if this was a systems analysis and design class, when you're designing things, involve the people who are going to be using the system, because they can tell you whether this is working well or not, what types of data that they expect to be on that form or that initial screen, and so on. So a lot of times, because of poor data problems, you're missing data, the data is incorrect, or mismatched data, or inaccurate information. So initially in this question, I was talking about the design problems. So you need to keep in mind that when you're designing a computer program solution to the way the business works, you typically need to understand the business process. What do I have to do in order to accomplish this task? How do I then put this into the database design? Then I need to go back and say, am I still completing that business process with my database now? And so this is a very cyclical process. You go round and round. And it may be that a business process that was manual, now you've automated it. Does that change the way we do things? I can remember when I went to college, we had to use cards and stand in line in the gym in order to register for classes. Well, if that was automated, do we still do those sort of things in that same kind of sequence? No. Now we have a totally different way of actually registering for courses. So think about if you were going to design the system of how you register for courses and make sure that you don't overload the courses, that students are able to register for the courses they're allowed to get registered for, and are they on track to graduate? So those are different types of things you could use the database for, and you can design it in such a way that it can help you implement that business process. I'm going to go ahead and end this particular video right now, and when we come back, we'll start talking about the database design development process.